Every AI model starts wrong. It learns by climbing down a mountain of error, one calculated step at a time. This is gradient descent, the engine of machine learning. Picture two model weights as coordinates on a flat plane. Now add a third axis, the loss, how wrong the model's predictions are. Together, they sculpt a 3D surface, a landscape of hills and valleys. Every high peak means high error. Every low valley means the model is closer to correct. Somewhere in this terrain lies the global minimum, the lowest possible error. At any point on this surface, we can calculate the gradient, a vector made of partial derivatives. It points in the direction of steepest increase in loss. So we flip it, taking the negative gradient tells us exactly which way is downhill. This single calculation drives every step of the descent. Real loss landscapes aren't simple bowls, they're complex terrain. Small dips called local minima can trap the algorithm, mimicking the true lowest point. Flat saddle points can stall progress entirely, with near zero slope in every direction. Gradient descent must escape these traps to reach the true global minimum. Watch gradient descent in action. Starting from a random point high on the mountain, it computes the gradient, then takes a step downhill. Compute, step, the loss value drops with every iteration, from a high starting error, down through the slope, converging toward the valley floor. After enough iterations, the path settles at the global minimum, where the gradient finally reaches zero. Each step follows one elegant formula: new weight equals old weight, minus the learning rate, times the gradient. The learning rate, alpha, scales how big each step is. Subtract that scaled gradient from the current weights, and you move a little closer to the valley floor. Repeat this update again and again until the loss stops shrinking. This whole process repeats in a simple loop. Start with random weights. Compute the gradient of the loss. Step downhill using the update rule. Check if the loss has stopped changing. If not, repeat. If converged, you found weights near the global minimum, a trained model. Let's recap. The loss landscape maps every weight to its error. The gradient reveals the steepest direction. We step opposite the gradient, scaled by the learning rate, again and again. Step by step, the model descends the error mountain until it finally reaches the valley of minimum loss.